Yeah.
Okay. Good afternoon, everyone. My name is Timothy, and today I hope to begin our presentation with something a little bit more interesting than blah 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 can be whatever. Or then, in case it fails, right, we have the video. Then we play the video. Oh, okay. So, ladies and gentlemen, presenting Climb With Climb our vision is simple: taking productivity to new heights. We want to help people work better in a world full of complex challenges. And this is especially important for PSA. Why, you might ask? Because Singapore is a maritime nation. The sea is our lifeline, and everything from the shirt I'm wearing to this television over here comes by the sea. PSA is therefore our strategic bridge to the world's economy. And we are here to help protect PSA's mission critical infrastructure as well as her most important assets, her people. So, over the next 15 minutes, I will be bringing you through why Climb benefits PSA, how Climb is different from other solutions on the market, as well as how we intend to bring Climb to PSA's terminals over our incubation period. We will then end off with a Q&A session. So, why Climb? Fuck my SMS. So, why Climb? Looking out behind me, we see PSA's workhorses, the quay and yard cranes. There are more than 600 of such cranes in Singapore alone, and every one of them requires inspection at least once a year. This is a job for Climb. Climb increases productivity by enabling more efficient inspections. Imagine a scenario where an inspector no longer has to manually work his way up a crane. Instead, he can send Climb to any of the 56 inspection points on the crane and inspect them safely via a high-definition video feed from the ground. In the process, we also avoid additional steps such as having to lower the boom of the crane. Climb can also inspect areas that are out of reach for human inspectors. Using its magnetic capability, Climb can scale vertically and reach places that are inaccessible to humans. Lastly, smart capabilities on Climb increase inspection performance. This reduces the risk of uncaught defects, which would then lead to costly, unplanned downtime for PSA. In any workplace, people are always the most important factor. That is why we always place their safety first. Climb increases on-job safety for inspectors by reducing their exposure to dangerous heights or machinery. This is the true value of using robotics for inspection, is that we get to protect our people who are performing duty on the front lines. But when we talk about inspection robotics, this other guy comes to mind: inspection drones. Although inspection drones may be fast and efficient for inspecting large structures, they may not always be the most appropriate solution. Operating drones are not as simple as what one might think. Drones are unable to fly close to or inside the interior segments of complex structures such as quay cranes. Therefore, they will not be able to capture the kind of images that we require to accurately diagnose and detect flaws on the surface of the crane. The low battery life of drones also severely limits the inspection workflow. Even high-end industrial drones do not have a battery life of more than 30 minutes. In addition, the loss of power for a drone is catastrophic as it inevitably leads to a crash. This endangers the people and equipment on the ground and also represents a large loss in investment. Autonomous drones are also more challenging to create as due to the sheer number of variables at play, especially if they were to be deployed in such a challenging environment like the port. Climb directly addresses the weaknesses of drones. Climb's onboard camera can capture images extremely close up to the surface of the crane. This will allow us to pick up even minute defects or flaws. The interior segments of the crane also do not pose a problem for Climb, as it does not have exposed moving parts such as rotors. Climb is also much safer than drones. This is because Climb uses permanent magnets to adhere itself to the surface of the crane. Even in the event of a catastrophic power loss, Climb will not plummet to the ground. As a more traditional robot, we can also implement time-tested, accurate positioning on Climb. This then opens up the doors for autonomous capability. So, that was Climb, a magnetic robot for crane inspection. I will now be talking about our progress as well as our development plan to realize Climb over our incubation period and beyond. Since last September, we have been actively working on ClimbBee. We have been experimenting and prototyping various new ideas and validated them with our faculty mentors. From here on, our roadmap to a minimum viable product will take place in 3 main stages. At every stage, we take collaboration with PSA's engineers very seriously, as we will have a specific deliverable that will be of direct value to PSA at the end of every stage. The first stage is the development of a test bed that will allow us to prototype ClimbBee's various capabilities. At this stage, we will work closely with PSA to determine the requirements for ClimbBee. We will be shadowing inspection engineers to understand their workflow and see where we can add value. We will be incorporating what we learn into ClimbBee's DNA from day one. From our previous conversations with PSA personnel, we also realized that safety was a recurring concern. It is at this stage that we hope to address any and all safety concerns. In the second stage of our roadmap, we start to implement smart capabilities onto ClimbBee. The first of which is a smart camera that implements a computer vision algorithm. This takes the form of an onboard camera paired with an artificial neural network. This will allow us to detect and classify flaws on the surface of the crane. Such a method of detection has already reached superhuman accuracy in other tasks such as the detection of cancer cells. Next up is localization and positioning capability for ClimbBee. We will be using a suite of internal sensors and external signals to implement inertial navigation for ClimbBee. This will allow ClimbBee to understand how much it has been moving and in which direction. We correlate this data with a 3D map of the crane, and this will allow ClimbBee to accurately determine where it is on the crane surface. In the last stage of our roadmap, we implement full autonomous capabilities for ClimbBee. This takes the form of 3 main components. The first is a vision-based self-driving algorithm that will ensure that ClimbBee keeps off the edge of the crane. Next is obstacle avoidance to ensure that ClimbBee does not create any accidents by actively allowing ClimbBee to avoid obstruction. The last is path planning. This will allow ClimbBee to independently navigate between waypoints on the crane. The value of this is that we can create automated inspection routines that ClimbBee can perform without the need for human inspection. Envision a scenario where a team of ClimbBee can be inspecting cranes 24/7, 365 days a year without the need for human inspectors. Now, I will be moving on to our business development plan for ClimbBee. ClimbBee's ability to scale vertical ferromagnetic surfaces is extremely versatile, and this ability is sought after in many industries, ranging from maritime, port and oil, to construction, power and manufacturing. In Singapore's maritime and oil industry alone, there are many corporations with specific users for ClimbBee. For example, Keppel can use ClimbBee to inspect oil rigs and other offshore infrastructure, whereas ST Marine can use ClimbBee to inspect the hull and superstructure of ships. It is a common saying that no plan is perfect. This is why at ClimbBee, we invest in our people and not the plan. Our team is comprised of 6 proactive and resilient individuals who believe in the same vision. It is these people that I'm proud to rely on to call out the flaws in our plan when the time comes and make amendments. These are the pioneers who are not afraid to iterate continuously in pursuit of higher standards. This is a team that believes in a better world by design. I am proud to introduce our team, Xiang Qian and Jian Yi, our roboticists, our mechanical designers, Dominic and Tanvi, who unfortunately cannot join us here today, and Fariha, our lead on business development. Their diverse skill sets complement and support each other to take their share of the burden and then some more. Our journey will be an uphill climb, but we will not face this alone. We have the support of our faculty mentor, Dr. Feng Xiaohui, who is an expert in autonomous robotics. He also did a doctorate in magnetic fields, so he knows a few things about magnets. Dr. Feng has also mentored previously similar projects such as an inspection drone for the deep tunnel sewage system as well as NParks. Being in SUTD gives us access to cutting-edge facilities for research and manufacturing that will enable us to make ClimbBee a reality. However, none is as pertinent as our partnership with PSA. We want to learn from your many decades of expertise and your mentorship and guidance will allow us to learn from the best of the best. At PSA's Living Lab, we look forward to collaborating with your engineers on the ground to validate Climb-B in a real-world setting. We look forward to your support to help us set a new industry standard for inspection and work on improving and innovating Climb-B every day. Today, we are faced with a choice. Let's make the choice to use Climb-B to increase on-job productivity and enhance safety for our inspection engineers. Support our vision for Climb-B, and Climb-B will support PSA's vision to be the world's port of call. Thank you. How long is it?